I'm Bob Duffy from Intel, and welcome to this Vodcast series on Intel oneAPI and CERN openlab. In this episode, we are talking with Silke Donayre, and she is an AI research student working with CERN openlab doing neural networks in the area of the Large Hadron Collider. Silke, welcome to the show.
Hi Bob, nice to meet you. As mentioned before, I'm Silke Donayre. I'm 25 years old and I'm half German and half Peruvian. I'm currently a computer science master's student at the Karlsruhe Institute of Technology in Germany. And well, I had the pleasure to work with CERN openlab as a summer student.
Fantastic. Thank you for joining us. And so I want to talk about your research and your experiments at CERN openlab. So at a real high level, just give us an idea of what you're working on there.
Well, I had to basically test Intel oneAPI with a neural network developed by CERN openlab. So I had to analyze the behavior of the neural network's training phase within oneAPI environment.
Fantastic. Now, I understand that you're using, in this process, you're using GANs, Generative Adversarial Networks. And I'm a digital artist. I always find this interesting because I see GANs always come up in really interesting things like Photoshop or movies where people are doing deep fakes and they can apply a different face onto an actor, right? But you're doing it in a different way here. Could you give us an explanation of how you're using GANs?
Yeah, sure. So the GAN we used for this project is for simulating the Large Hadron Collider's detector's response. So in a deepfake, it is like you have a video with a person on it, and you have as another input an image of the face of another person that you would like to have on the video. So with both inputs, you just generate a new one, a new output, but with a combination of both. So in CERN, you have as input the properties of a particle that enters the detector volume, and as an output, you get the energy response that the calorimeter would have with such particle. So, you're basically generating something new with the inputs that you have provided to the model. And, well, the goal is to use GANs to replace Monte Carlo simulations.
Okay, fantastic. So is it like more efficient, faster than using Monte Carlo simulations, or just a new way to do it?
Well, the thing is that with GANs, with less resources, you can also get what you get with Monte Carlo simulations, because in the future, the resources at CERN are not expected to increase. But the computation is going to increase. So we need a new approach that could achieve the same as Monte Carlo simulations, but with less resources.
Okay, fantastic. So ideally, what comes out of these experiments for you? Obviously, you're going to have more efficiencies with a GANs approach versus Monte Carlo simulations, but what do you hope will come out of your research?
Well, it would mean that we would have an underlying layer that would provide a compatibility between different hardware architectures. So nowadays it takes time to migrate one code for one architecture to another one, because we would need new frameworks or different libraries. And well, with oneAPI, the development of code would be much easier and we wouldn't need to make those changes.
Okay, fantastic. So have you seen performance improvements in this, or any performance gains in what you've done?
Yeah, well, actually, with oneAPI, the neural network converged faster. So beside of having this feature of running on different architectures, it actually also improves something on the neural network.
So in this, well, it's amazing the kind of work that you guys are doing over there, and you're finding new ways to achieve these things, and you're using technologies like Intel oneAPI. So is there anything that kind of was a standout moment for you in this process in your internship?
Well, yeah, actually, well, I was very excited at the beginning of the project, because the idea of having an API that would allow you run your code through different architectures was already like amazing, because it would mean that we would save a lot of time in developing programs that need to run over different architectures.
So Silke, you're doing amazing work. How do you even begin to explain this to somebody who's not a physicist or an engineer?
Well, you know that there are different types of hardware. You have the most common ones, the processors, and also the graphic cards. So when you start developing a program, you just look on which type of hardware architecture are you going to develop it. So you just start coding according to it. And the problem is when you want to run that code on another hardware, you will have to modify it, and that is really time consuming. And well, with Intel oneAPI, you can do that without making any modifications. So it's a tool that already does that for you. And yeah, that's amazing on that. And my project was just about testing that tool with a program developed by CERN openlab.
Well, that's fantastic and well explained, Silke. But so what's next for you? Where do you go from here?
Well, I'm currently working on my master thesis. I'm also still working with neural networks, but in this case, I am developing a compression method using autoencoders for scientific data. And well, after that, I will keep working on the AI field, trying to solve problems that will make human life better.
Oh, well, no doubt that you will. So, Silke, this has been an amazing conversation, and thank you for joining us today.
Thank you very much for having me.
For more information on Intel oneAPI, follow the link below to the Intel Developer Zone. And if you like this content, please click like and subscribe to the YouTube channel. And on behalf of a fantastic video crew, we thank you for joining us today. Until next time, I'm your host, Bob Duffy. We'll see you later.